To represent the inequality, choose 2 points, one above and one below the boundary line, and substitute each point in the inequality. The point that satisfies the inequality is in the wanted region, and the point that doesn't satisfy the inequality is in the unwanted region. The unwanted region is always shaded. Consider points 1, 1 and 2, 5. Point 1, 1 is below the boundary line y is equal to 4 and the y value 1 is less than 4. Therefore, point 1, 1 is in the wanted region since it satisfies the inequality y is less than 4. Similarly, for point 2, 5, the y value is 5, which is greater than 4. This shows that point 2, 5 is in the unwanted region since it does not satisfy the inequality. This means the region above the boundary line is the unwanted region and is shaded as shown below. Example 2. Represent y is greater than or equal to 2. Solution. The boundary line is y is equal to 2. For an inequality with the symbols greater than or equal to or less than or equal to, the boundary lines are drawn using a continuous line. This means that points on the boundary line are included in the wanted region. Draw the boundary line y is equal to 2 using a continuous line. Note, the shaded region is the unwanted region. The points on the boundary satisfy the inequality y is greater than or equal to 2. The points on the line satisfy the inequality y is greater than or equal to 2. Example 3. Represent x is greater than or equal to 2 graphically. Solution. The boundary line is x is equal to 2 and the wanted region is the one where an x value is equal to or greater than 2. Graphical representation of inequalities involving two unknowns. Example. Draw a graph of the inequality 3x plus 4y is equal to 12. Solution. The boundary line is 3x plus 4y, which is equal to 12. Make a table of values of x and y for 3x plus 4y is equal to 12 on the Cartesian plane. Draw the boundary line using a broken line. Plot this on the Cartesian plane. When x is 0, y is 3. When x is 4, y is 0. Solving simultaneous linear inequalities graphically. To solve simultaneous inequalities, draw the inequalities in one graph. The solutions are given by points in the wanted region. Example. Draw graph of y is less than or equal to x plus 3, x plus y is less than 4, and y is greater than or equal to 0, and show the region that satisfy the inequalities. The following is the required graph. Inequalities from inequalities graphs. In this lesson, we shall define a region which is already graphed by determining the inequalities that satisfies the region. Example: state the inequalities that represent the unshaded region R in each of the following areas. Case 1. The gradient of line 1 is 0. The line cuts the y-axis at 2. Therefore, using y is equal to mx plus c, the equation of the line of all the points in the line y is equal to 2 is always 2. Similarly, line 2 cuts x-axis at 3 and the x-coordinates of all the points on the line is always 3. Therefore, the required line is x is equal to 3. Step 1. To find the equations for the boundary lines A, B, and C.